Hey, good morning, ladies and gentlemen. As you can see, I am not with you this morning. So please, I just ask for your patience and help to one another as I'm going to try to guide you via this video through maybe part of today's lesson. First thing I'd like, if you know, and we do this every morning, beginning of the lesson, if you can pull out the bell ringer sheets that you have. The one thing I left off yesterday when we left class because we ran out of time was I need you to complete number 21, and most of us probably have not done it because we did not have a graphing calculator. So if you could get up, go grab a graphing calculator, and I'd like you to open your books up to page 289, and I want us to try number 21, all parts, A, B, C, D, and E. See if you can, again, remember how to load the calculator, and then also how to find the equation so you can answer the questions that come with it. So if you don't mind, they're going to grab calculators, they're going to find a seat, they're going to open their books, and they're going to complete this problem. If you can pause the video now, and in a little bit I'll come back on and go through and double check we could do all these pieces. Thanks. So I'm not going to go through the entire problem with you, but I do want to just maybe quick refresh in case you got stuck in the process. If I want to, again, add this data to find a line of best fit, I need to go to the graphing calculator. If I find it, and again, if you didn't remember this, the quick review is this. I need to enter my data. I'm going to go to Stat, so Stat right in the middle of the page. And then if I hit Edit, this is where I find my two lists. And then again, if I want to clear list one, I'll highlight list one and hit Clear. And I'll go over to list 2, and I want to clear that out and hit clear there too. Well, now I can actually enter my data, my independent variables in list 1, my dependent variables in list 2, and those come from the table on page 289. After I do that, again, I can go back to Stat, and if I want to find my line of best fit, it's under Calc, and if you scroll down the menu to number 4, you'll find now that taking list 1 and list 2, it's actually going to find your line of best fit, or what's called your linear regression. If I hit enter, nothing's going to show up for me because I don't have a function, I don't have any data set in there, but you would actually get something. So forgive me there for leading you astray. So hopefully you were able to do that. I know the answers are on the back of the book, so you can check them there. When I get back, I might be back before class gets out, and we can go through if you have questions on it. But I am going to want you, as we approach next Monday, our test, I am going to want you to be able to find a line of best fit from a set of data, answer questions based upon that line of best fit, what it might be. So today, though, if the sub, I guess, kind of two options here. I should be coming back to class in a little bit here. What I might ask, actually, here's what we'll do. I'm going to go through this via the video with you. If I get back, then I can answer whatever questions that you might have. And so today, we're going to go take a step forward, and we're actually going to look at not linear functions, but we're going to look at the next degree up, and we're going to look at quadratic functions. The notes are on eBackpack, if you want to go there and follow along and check there. But it would be helpful if you wrote these things down and put them in your notes. The more you write, the more you'll remember. So we're going to use properties of quadratics to graph and analyze the function so that tomorrow we can actually do some things with quadratics and make predictions with quadratic functions. As I go through the video, again, if the sub would just pause it, if they need more time to write things down, that'd be awesome. So here's where we're going to start. We've all been through it. Algebra 1, Algebra 2, you've seen both of these before. Quadratic functions. What's a quadratic? We've talked about how to solve quadratics a few weeks ago. Now, what's the general form of these functions? And there's really two basic ones that we use, and both serve different purposes. So the first one, the general form. Yeah, Angelo. Hey, I'm glad Angelo got it. Angelo, gosh, thanks for stepping up and helping out here. You're right, Angelo. The general form is simply ax squared plus bx plus c. Gosh, I don't even need to be here. That's awesome. Now that the other form, that's the one we're most familiar with, setting that equal to 0 and factoring and using the quadratic formula, etc. The other one's called vertex form. In the vertex form, this is similar to the equation of a circle, except for it's different because it's a quadratic. But vertex form looks like this, where we have a times x minus h squared plus k. And as you look at this, again, f of x is your y value. But as you look at this, it's x minus h, and h is your x coordinate for the vertex, and then just plus k, and k is the y value for your vertex. And notice all those are is transformation. So it's shifting at h units right or left, and then it's going up or down k units because that's outside. So those things should look familiar. And so we're going to use these two. So please write them down, circle them, highlight them, because they're going to be useful as we go throughout the rest of this lesson. Be a great time to pause it so they make sure they get them jotted down. I just want to take you through, if you don't mind, 2 examples of how to use these, maybe 3 examples, how to use these to be able to graph equations and do it fairly easily. First example, I call this option 1. The book calls this graphing by using transformations. I put this in italics here of completing the square is the method that we're going to use. So way back in chapter 1, we talked about in chapter 2 how to complete the square. We're going to come back to that concept now and actually put it to use so we can graph this quadratic. So how's completing the square work, and how's this work by transformations? Well, your goal here is going to be, can I write this and get this in the parabolic form, or in vertex form here. So our goal is to convert it from standard form or general form into vertex form so I can easily look at the points and graph it. And how we do that now with a function that's written in this general form is we want to, again, isolate the first pieces here so we can complete the square and write this as something squared equals something over here. So I want to get it into that same format as what you see here, where again we have something squared plus or minus something. I want to get it in vertex form because it's faster and easier to graph it. So completing the square. How does it work? I need to get these things by themselves. I need to add the 1 over. What's different now is that you actually have something on this other side. It's not just set equal to 0. So I actually have f of x plus 1 is equal to, I'll move this out of the way, my x squared minus 6x. Now, completing the square again works like this, where I take whatever that second term is, in this case negative 6, and what I'm going to do is I'm going to add negative 3 squared. So I take half of that value, negative 6, and I square it to this side. Now the reason why I do that is because down below again, I can write this as a perfect squared binomial. And if you remember the rules again, the rules are this: it's going to be x, what? X minus whatever that half was. In this case, minus 3 because it's a negative 3. And because we're dealing with algebra, the only place where equality exists in the world, if I added this to this side, I actually have to add 3 squared or negative 3 squared to the other side, so I actually have to add 10 to this other side. So technically on the right-hand side, I have f of x equals, f of x plus 10 equals my x minus 3 quantity squared. Now, some of you, maybe you can see this, but we're almost done because now the last step is this. Can I get f of x by itself? Can I move this 10 back over? Sure, subtract it over. And in doing so, we're left with f of x equals x minus 3 squared minus 10. And now the beauty of this now is this is in vertex form. If I asked you to look at this, what's the center of my, or the vertex of my parabola? The vertex is it's going to be x minus whatever it is, so it's going to be positive 3. That one's always opposite what it looks like, just like in a circle. And then this one is negative 10, so x is 3, y is negative 10. That's my vertex. If you can find the vertex of a parabola, then you have the battle pretty much won. And I'm going to ask you here if you could draw a simple graph here and maybe make a coordinate system. Where is 3, negative 10 at? So if I go over 3 and down 10, 1, 2, 3, 4, 5. That's going to be the vertex of my parabola. Now this parabola, I don't know if you remember this from our days in Algebra 2 or from wherever, but because there is nothing in front of this, there's actually a positive 1 in front of my x squared. Likewise, there's kind of like this invisible positive 1 in front of here for my a value. That means my parabola is going to open upward, and so it's going to look like a big smiley face here. And if I want to find out how it looks, the easiest way we do this, again without a calculator, is if I made a little t table, an xy chart, and I'm going to use again this function right here, make this easy. But if I know the vertex is at 3, negative 10, I know that my points are going to be symmetrical on both sides. So if I chose, say, 2 on this side and 4 on that side, they're the same distance away, the y value should be the same. So if I plug 2 into my x, so if I plug it into my x, 2 minus 3 is negative 1. Negative 1 squared is 1. 1 minus 10 gives me a negative 9. If I plug 4 in, the same thing happens because 4 minus 3 is 1. 1 squared is 1. 1 minus 10 is negative 9. These points are symmetrical with each other. If I chose 1, if I chose 5, I should get the same values here. And if I plug 1 in, I'm going to have 1 minus 3 is negative 2. That squared is 4. 4 minus 10 is negative 6. You'll notice if I plug 5 in, you're going to get the same value because 5 minus 3 is 2, and that squared is 4, and 4 minus 10 is negative 6. But I can actually now graph my parabola. And I'm going to do this so you can see it a little bit easier. But if I go back up now, you can plot these points, and you should get a nice looking parabola. So if I go over 2, it's going to be down 9, so my point now is going to be here. So over 2, down 9. If I go to 4, it's going to be the same thing, but it's on the other side. If I go to 1, I'm at negative 6, so 1, 2, 3, 4, 5, 6. And if I go to 5 over here, it's going to be the same thing. And again, I would be happy if we got at least 5 points here to draw our parabola. So here's the first option, and some of the problems you're going to have to do it this way. If they ask you to graph by using a transformation, what they're asking you to do is to find the vertex and shift this thing 3 to the right and down 10. And so I have a parabola that's shifted 3 to the right, down 10, but the way I do it is writing it in vertex form and completing the square is the process to do it. That's probably the hardest one potentially to look at and do. But we want to change this to vertex form. Now you know I have to make your life harder because that's my job. And so if I use the other form, use that standard form, there it is again, ax squared plus bx plus c. If you remember from our days in algebra, there's actually a shortcut in finding the vertex if it's straight into that form. And instead of asking Angelo again, what is it, because I'm sure you would spout it off because he knows it, and that's nice and that's helpful. I just put them on the board for you so you could write them down again. But from the general form of ax squared plus bx plus c, if I want to find the vertex hk, h is equal to negative b over 2a. And k, it's a little more complicated, but you can find the y value, the k value of 4ac minus b squared over 4a. Again, I would put these in my notes, circle these, highlight these, because these are nice, easy, fast shortcuts for us to get to where we need to get to. If A is the key here. If A is positive, that's what this is saying. If A is greater than 0, it's positive. Then it's going to be a parabola that's opening up. If A is negative, less than 0, it's going to be a parabola that's going to be opening down. Not very happy. But if the sub again would pause the video, take a moment, write these down. We all need these, right? So some of us, I can tell, we're probably getting off track right now. Feel free to sub, yell at them if you need to. But we need to get back on task. Please write these down. Help your neighbors out. Now, I showed you these because the second method here, the second option, I'm calling it option 2 here. Graph by using properties. They want us to use this whole general form now to do this. So we're not going to convert this into vertex form. We're going to leave it in this general form. So you might say that's easier. But what I need now is those two formulas and understand if I'm going to find the vertex, if I'm going to find H again is negative B over 2A. Could I go through now and find the vertex of this and just do some plug and chug? So what is H? Well, it's going to be negative, and since B is already negative 3, it's going to say like negative of a negative, which means this is really positive 3, over 2 times A. A is the number in front, which is 2. And so my answer here is going to be 3/4. So H is going to be 3/4. If I want to find what K is, the Y value, the formula from the other page here again was 4AC minus B squared all over 4A. And so finding that is simply, again, plugging it in of saying 4 times A, which is 2, times C, which is negative 2, minus negative 3 squared all over 4 times A, so 4 times 2. It's a little more math here, so let's see, 4 times 2 times negative 2 is going to be a negative 16, minus 3 squared is, negative 3 squared is 9, all over 8. So a little more intense, but I'd end up getting a negative 25 over 8. And that's my K value. So what's the vertex of this parabola? It's not a very nice point. And maybe I might even go a step here farther and say, okay, as I look at this, probably not the easiest to graph this the way you see it right now, but oops, I'm losing it all. But K itself, if I simplified this and wrote this as a mixed number, 8 goes into 25 3 times. There's going to be 1 left over, so I'll have negative 3 and 1/8. So maybe that's a better way to write K. So process still the same now, where I can find the vertex, and the vertex now is going to be going over 3/4. So 3/4 is right in between 0 and 1, closer to 1. And then I have to go down 3 and 1/8, so down 1, 2, 3, and then an 1/8 is going to be just below here. That's going to be my vertex. Oops. 3/4, comma, negative 3 and 1/8. So that's my vertex. Now, you could make a t-table, but this is actually messy to make a t-table here because these are not nice points. And you're probably not going to get nice values out of this, which is unfortunate. So here's another alternative, and this is where I'd ask you to go if you're going to do this by using properties, is I'd maybe ask now, can you find the x-intercepts, and could I find the y-intercepts? So again, I'm going back up here to my equation. Here's my quadratic. If I asked you, how do you find the x-intercepts? I need to set y equal to 0. If I set that equal to 0, make my function 0, I have 2x squared minus 3x minus 2. And what I might try doing is see if this factors. And I believe this does factor, so 2x and x. When you get 2 on the end, you're going to have a 1 and a 2. And I think this works because you get 2 and you get 2. Mr. Roy, that doesn't work. So let's go back here. So let's switch this up and stuff and put my 1 with this one and my 2 with this one. See if this works. I'd get 4 there and 1 there. Does 4 and 1 give me negative 3? Sure. And so my signs here are going to be, since I need a negative 3, I need a negative with that and a positive here. So what are my x-intercepts? If I set this equal to 0, I'll have x equals negative 1 over 2. So subtract the 1, divide by 2. If I set this one equal to 0, I'll get x equals 2. If those again are my x-intercepts, I can plot those and just go up to my graph. Where is x equal to 2 at? Right here. Where is x equal to negative half at? Right there, in between. And I know my graph has to go through those 2 points. The other point you can find very easily is you can find your y-intercept. And the y-intercept again is if I make x 0, and this one's even easier. So take a look at your deal. If you make x 0, this is going to say y equals negative 2 because this goes to 0 and that goes to 0. So can I graph y equals negative 2? Well, sure. That's right here. And this would give us enough information. And since, again, my a value is 2, that's positive, so my graph has to open upward. And I can draw my parabola like this. So difference here is I didn't plot and make a t-chart just because it was going to be messy, and also because by using properties. So another option is you can find x and y intercepts, and that gives you enough information to adequately sketch a graph of what your parabola looks like. The last thing, and again, I know we're tired of this and stuff, and maybe Mr. Roy will be back by now, but the last thing I'm going to ask you is this. Last example. And then you should have some time to work. Some of us hopefully can get online and do some of our online homework too with it. But the last question is this. Find the vertex function, find the quadratic, function whose vertex is 2, 5, and passes through 3, 2. So if they want us to write the equation for this, notice what they're giving you. They're giving you the vertex. And they're going to give us a point then also that it goes through. Of the 2 forms, since they're giving us the vertex, of the 2 forms, which one do I want to use? The general form or the vertex form? Sweet, yes. Say it again, is that Goy? Goy. You really? Goy, thank you. You're taking Angelo's place here. But yeah, I want to use the vertex form. So vertex form again is my y equals a x minus h squared plus k. If I use that form, what can I do? I can simply plug in what I know. So what's my h and what's my k? Plug them in. So I have a, but then I have x minus, in this case 2 squared plus 5. Now the only thing is, here's my only issue right now, last issue, and we're almost done, is that's right, except for there's one thing I don't know, and that one thing is I don't know what a is. A is some, again, dilation, some stretching of our function, whether it's making it smaller or making it bigger. And I need to find a. And so the only way to find a, though, now is to plug in my point because it goes through there. In my point, this is an x and a y. Plug those in. So when I plug the 2 in, the 2 is going to go where my y is, so f of x. A I still don't know, but then here my x value is 3 minus 2, quantity squared plus 5. Could you work backwards and solve for A? Sure. Maybe I subtract 5. I can subtract 5 and do it on both sides. So negative 3 equals A, and then in parentheses here I'm going to have 1 squared, which is just 1. So this really says A equals negative 3. So if that's the case, what's the equation in vertex form? My equation is going to say y, or f of x, equals negative 3, x minus 2 squared plus 5. And if they ask us just to write and find the quadratic function, there it is. So it's getting shifted to the right 2, up 5, and it also has a reflection that's going to be over the x-axis. So it's going to go opposite. It's going to go down and get stretched by 3 because of the function. So there it is. Not that this is the shortest, easiest thing in the world. A little bit of mess, a little bit of work. Some of you, again, we might have to go back and look at our notes. If you want to go back and look at this video, it's on my webpage. And the notes, again, are on eBackpack. But now the rest of the period, and again, hopefully I'm back by now, but the rest of the period, I'm going to ask this. I want us to look at page 299. Try these questions. Some of them are going to be quick and easy. If they ask you to use the properties, then we need to use the properties like example 2, the option 2. If they ask you to use transformations, that's another way to saying put it in vertex form. So we need to put it in that format, find the center, plot the points. So help each other out. Again, I apologize for missing part of class. And let's make this a great day. So I appreciate your efforts, and I will see you shortly. Thank you.